Daniel, I don't know if you want to say just a few words before
Yep.
the 3 projects.
So now we will have 3 presentations dealing with 3 ongoing European projects within the framework of FP7. The first presentation will be given by Eunate Goiti from Tecnalia, Spain, and it will be about the AEROCOINS project, working mainly on aerogel-based composite. Eunate.
Okay, good morning, everybody. Thank you, Daniel, for the presentation. So, as he said, my name is Eunate. I'm working in Tecnalia, which is a private research center located in the Basque country in the north of Spain. And today I'm going to present to you our AEROCOINS project. That AEROCOINS stands for Aerogel-based Composite Hybrid Nanomaterials for Cost-Effective Building Superinsulation Systems. So basically the motivation of our project is to support the objectives we've got in Europe in terms of reduction of CO2 emissions, and also to support the improvement of the energy performance of our buildings. So one way to do this is to improve the thermal insulation of the building's envelope. So how can this be done? If we go to our traditional building insulation materials, if we want to improve this insulation property, we will need to use thicker insulating layers. And as Daniel and Paul has already stated, there is a big issue concerning the space limitation. So this is not always possible to use this kind of materials because we could end up with buildings like this, and it's something that we don't want. So what else can be done? So we can use the superinsulating materials, and one of them is are the aerogels. What happens when using aerogels? That the thickness of the insulating layer is reduced, as you can see here in the graph. And this is thanks to the low value of thermal conductivity of this kind of material. So Daniel has already described well what are aerogels. Just say that for the building application, the silica-based aerogels are the most interesting one, because you can have organic-based aerogels, but silica-based are the ones that have most interest for the building application. Just said that these materials are very weight light, with a high core volume percent, up to 99%, low density, and a very high specific surface area. All these aspects are responsible for the low value of lambda, of the thermal conductivity at ambient conditions. However, why this product that is so good hasn't been used yet in our buildings? Because we think that there are still 2 challenges that we need to target, and those are the mechanical properties. So plain silica aerogels are fragile materials, so the mechanical properties need to be improved. And the second challenge is that we still need to lower the production cost of this kind of materials. If we have a look at the products we've got nowadays on the market, so basically there are aerogel granules and aerogel blankets. And at the moment, when preparing this project, we saw that we had ahead one commercial challenge, that was the production of monolithic aerogels by ambient drying. So this is basically our main goal or our general objective of our project. So AEROCOINS is funded under 7th Framework Program. It belongs to this research area from the EACI. It has a duration of 4 years. It started in 2011, so we are basically running on our 3rd year now, with a project cost of 4.3 million euro and a project funding from Europe from 3 million euro. So I'm the current coordinator of AEROCOINS. So have already told you which is our general objective, but we've got some specific scientific and technical objectives to meet. So those are, the first one, we want to synthesize, to elaborate a reinforced superinsulating silica aerogel, basically based on two strategies, coupling silica and cellulose, and also incorporating cellulose-based nanofibers. The second objective is that at the same time we want to develop an ambient pressure drying. The third one is the aerogel material we are going to develop within AEROCOINS is going to be part of a building component. We need to design an appropriate building component in order to install our aerogel material on the walls. And the last technical objective is to demonstrate the cost reduction of our product in comparison to the traditional products we've got on the market. So who we are in AEROCOINS? So we are 9 partners, 5 research centers, VTT, Arminius, EMPA, SAE, and Technalia, 1 university in Poland, the one in Lodz, 2 big companies, Acción Infraestructuras and PCAS, and 1 small medium enterprise, Separex. And what is the methodology, the way we are working? So we have a start at a laboratory scale, working on the new formulation of the aerogels. Then at the same time, trying to optimize, to design a new ambient drying procedure. Once that we have chosen the best formulations, we are going to, actually we are doing the upscaling of the aerogel material. Then we have to prepare our components and finally do the demonstration. So basically, this is the work package leaders. Basically, we go from the lab scale to the real scale. So as you all may know, when preparing aerogels, there are 2 main steps, generally speaking, and it's here represented. On the first part of the preparation, basically concerns the preparation of a wet gel. And on the second part of the fabrication is the drying step. So work package 1, we have been working on this first part of the synthesis, trying to do new formulations on this area in order to get a reinforced structure. So how has been done? We have been using 3 main reinforcement approaches. The first one, using cross-linking silica cellulose hybrid material. The second approach has been using synthetic polymers, doing some cross-linking. And the third one, introducing cellulose-based nanofibers. These have been the 3 main approaches. On the second work package, we've been working on this second step of the aerogel fabrication. That is very important stage, actually, because you have to remove all the solvent you've got in your wet gel and do it in a way that the nanostructure is kept in order to keep a low value for the lambda. So in AEROCOINS, we are promoting ambient drying because we think that will permit to introduce a continuous process, so what means to lower the production cost. But even that, we have also used supercritical drying for preparation of reference materials. And there are some basic characterization that we need to do with all the material we are developing. And those are thermal properties, mechanical, resistant to fire, and water absorption studies. So, well, this is a picture of some of our silica reference materials. And just say that this year, in June, we had our first milestone. So in that time, it was decided which is our formulation, which is our drying process that now we are doing the upscaling. So we have substance formulation, and now at this moment, we are working on this work package 3. We are upscaling these small lab-scale samples to 50 by 50 centimeters square board. So, and as you can imagine, so during the upscaling, you always encounter some difficulties, problems that you didn't have at the laboratory scale. So at the moment, we are working on this. Once that we have our big aerogel board, reinforced aerogel board, we will design, and we have already started to design an appropriate building component. With this, I mean we are not going to install our aerogel boards straight on the wall, but we are going to, let's say, like encapsulate this aerogel board before putting that in the building. So we need to design an appropriate component. And then in work package 5, we hope to start this validation activity early next year. We're going to monitor, we're going to validate our product in 2 different scenarios. In this building, that is cubic building, that we have it here in Tecnalia in Bilbao, that it's an experimental building. And also we are going to do our demo activity in the demo park in Madrid. So these are going to be the 2 scenarios. What we are aiming to obtain from these demo activities. So the results we want to get are what are the energy and the CO2 emission savings, also to evaluate the durability of our products, study any thermal losses through the structure joints, also to evaluate or to identify any thermal breaches, and also we are going to measure the air tightness. So I want also, this is concerning AEROCOINS, but AEROCOINS together with other projects, we are members of the NANO cluster. That was an initiative from the project officer George Catalagarrienakis and PTA Marcel Yerselhuis. This NANO cluster started 2 years ago, and the main objective is to join efforts to find ways of collaboration and cooperation between the different projects that belong to this cluster. And so far we have done some activities together. One of them actually is the demonstration activities, because on this demo park in Madrid, different mock-ups, different houses have been built up in order that the projects can do the demo activities there. So far the members of this NANO cluster are these 6 projects. Some of them are already almost finished, some finished. So these are the 6 projects that have been developing different technologies. And within this NANO cluster, so we are having our general meetings. We have done some common dissemination activities, the last one during the Euro Nano Forum Congress in Dublin this spring. We have also edited a cluster promotional video. So we have done some demo activities, as I have already explained to you. And now we are on, so this cluster is going to grow up, new projects, new members are going to join in this cluster. And so we are very, we expect to grow up more and to do more activities together. So thank you very much. And if you've got any questions regarding AEROCOINS or regarding the NANO clusters, you can always contact me on this email address. Here you've got AEROCOINS webpage, what you can have a look. So thank you very much.